Okay, our last major concept in our stoichiometry in the mole unit is to talk about ways to use the mole unit to describe solutions. And I remember solutions are dissolved compounds. Okay, the first one we're going to talk about is the concept of molarity. Now, we've talked about that when we're working with like solids, we can simply weigh them out on a scale. However, when we're working with solutions, and we're no longer working with things that are easily placed on a scale, we're looking at basically a certain amount of a compound that's dissolved in a total volume of solution. And that gives us what we call the molarity formula. Molarity is always represented by capital M, and that will be the moles of the compound per liter of solution. This is our formula. Now, the trick to remember is that this is not grams per liter. However, almost all molarity problems are going to give you grams, because that's how we measure out substances, is we weigh them out. So you are going to have to convert from moles to grams or grams to moles. Okay, let's look at an example problem for molarity. Okay, so we need to use our molarity equation. So the molarity will equal moles per liter. Now, let's look at our problem. It says grams. Grams are not moles. Moles are not grams. I will have to convert these grams into moles first. Secondly, this says liters, this says milliliters. I will have to convert the milliliters to liters before inputting it in the equation. So I will have to convert grams to moles. That's my first step. Okay, if you remember from doing mole conversions, I'm going to have to take the 3.9 grams times 1 mole over molar mass. And look, it's a compound. So I need the molar mass of Na and Cl. I have to add those two things together. Okay, Na is 22.99. Cl is about 35.45. I'm using a slightly different periodic table than the one you guys are used to. I'm going to add those two together. So 22.99 plus 35.45 is 58.44. Okay, I will remind you that when you do your problems, I need to see your work when you are finding molar mass for everything except an element or a diatomic element. Okay, so I need to take the 3.9 divided by 58.44. Okay, and that equals 0.0667 moles. Okay, 1 unit down. Okay, the second thing I'm going to have to do is I have to convert milliliters to liters. Okay, always read your problem carefully, because sometimes the volume is given to you in liters, sometimes it is given to you in milliliters. If it's given to you in liters, no conversion is needed. The number can just be plugged in. If it says milliliters, you have to do the conversion. Milliliters to liters is really easy because you just take the mils divided by 1,000. Okay, which is going to be 0.125 liters. Okay, so now I'm going to take this number and this number, and I'm going to input them right into my equation. So M, the molarity, will equal 0.0667 over 0.125. And my answer will be 0.5336. I get two significant figures. So the molarity is 0.53. You say, what's the unit? Moles over liters. Moles per liter. Okay, one more very quick example problem. Okay, this is the other common form, if you will, of the problem. How many grams of KOH are needed to make 400 milliliters of a 0.55 molar solution? Alright, let's see what's provided to us in the problem. Okay, we have a volume, but it's in milliliters, not liters, so we'll have to convert. And then we have 0.55 molar. Well, where does that go? Here. So if you look at the problem, what are we going to solve? We're going to be solving for moles. What are we going to do with the answer? We're going to have to convert from moles to grams. Okay, so let's take our 400 mils. Okay, remember you divide by 1,000. Okay, and I'm going to substitute. The molarity is 0.55. Okay, how do I substitute? I'm going to multiply both sides by 0.4000 to get rid of on this side and just have moles. Okay, the important thing to remember is I just solved for moles. Moles are not grams. I must convert 0.22 moles to grams. Okay, the mole goes on the bottom, so that's 1 mole. Well, what do I need here? I need molar mass. I have to find the molar mass of KOH. So I have 1 K, 1 O, 1 H. K is 39.1. O is 15.999. H is 1.0079. Okay, let's add them all up. Okay. 56.107. That's the molar mass. So I just need to multiply this times 0.22. Okay, I get two significant figures. This has 4, but this only has 2. Remember, zeros in front of the decimal are not significant. Okay, so I'm going to round it off. For the answer, my calculator is 12.34. Round that off to 12 grams. Okay, 2 sig figs. Okay, the other thing that we commonly see using moles and concentration, or describing a solution, is called dilution. Dilution is basically adding water to a more concentrated solution okay, and it gives you a diluted or less concentrated solution. Okay, the important thing for us to remember is that we're going to be adding water. So this is a solution, which means it has something dissolved in it. We're going to be adding water, so we're not going to change the amount of substance that's dissolved. However, we're changing how much of it would be in a particular volume. So here is our equation. Remember, capital M stands for molarity. This is the molarity. This is M1 times V1 equals M2 times V2. V stands for volume. So this is the more concentrated, and this is the diluted, or less concentrated. So this is a 4-variable problem, so we'll need to know at least 3 out of these 4 variables. All we'll do is plug them in. Now in this case, the volumes do not have to be in liters, but the volumes have to be in the same unit. So if it's milliliters on one side, the answer is milliliters on the other side. If it's liters on one side, it's liters on the other side. So the only thing you have to watch for in these problems is to ask yourself, if I'm finding volume, what's the unit that I'm given? What's the unit I'm supposed to find? Well, I have to convert between milliliters to liters. Okay, so let's look at a quick example problem. The nice thing about these problems, there's no molar masses. Okay, so this is what the problems typically look like. Okay, so I have a more concentrated solution, 18 moles per liter. Okay, I need to know how much of that will I need to take out and add water to get to a final volume of 650 milliliters of a less concentrated 2.5 molar solution. Okay, so remember, the word of connects two numbers that go on the same side together. Okay, so this is the less concentrated solution, so this would be M2. This is the volume of the less concentrated solution. This is V2. This is the more concentrated solution, so it's M1. So we must be solving for V1. So let's plug in our numbers. So it'll be 18 times V1 equals, this is the less concentrated, 2.5 times 650. These are my multiplication dots here. Okay, so on this side I just simply have to multiply the two numbers together. So 2.5 times 650. So we've got 18 times V1 equals 1,625. Okay, so I'm going to divide both sides by 18. Okay, 2 sig figs. So 1625 divided by 18 is 90.2. How do we make 90.2 to have two significant figures? I leave the decimal point on the end. So that makes this 0 significant. So 90 point mils, not 90.0, that'd be 3 sig figs. Okay, that's all dilution problems are. Okay, they're just going to give you, you might be finding M1, M2, V1, or V2, but you'll have all of the rest of them. You just have to read the problem carefully and decide which one's the more concentrated, which one's the less concentrated or diluted. Okay, and are you having the volume of the less concentrated? You have the volume of the more concentrated that's given to you. All right, good luck.